Okay. Yes. Am I audible? Hello?
Yes, Divya ma'am, you're audible.
Okay. I welcome you all to the third session of fourth day of 1 week.
Divya ma'am,
Yes.
your voice is echoing.
Hello?
Yes, now it is okay.
Okay. So we are pleased to have Dr. Bala Ramudurai sir and Professor Mitri Kacharavi sir as a speaker in today's session. They are going to address on the topic that is technology forecast. Before starting the session, I would like to give brief introduction of our guest speaker. Bala sir is an author, coach, consultant, and professor. He has authored a book on design thinking called Karmic Design Thinking. He has 3 patents to his credit and more than 10 publications in international research journal. He's a co-founder of Triz Innovation India. His teaching experience includes design thinking and creative problem solving at different universities, including IIT Madras, IIT Gandhinagar, IIT Hyderabad, and universities of Mexico and Malaysia also. We have our next guest, Mitri Kacharavi sir, is currently working in Polimi. He brings over 20 years of practical and research experience in theory of inventive problem solving as engineer, researcher, consultant, and teacher. Currently, he combines the practical consulting with research and technology forecasting of systems evolution and problem solving. So I would request you, sir, to start the session, and we are thankful that you are here in our session. Thank you.
Thank you so much for inviting us. Professor Dimitri and I are indeed very thankful for having us over here and to share our experiences on technology forecasting. To give a little bit of history about our association with each other, first of all, Professor Kucharavi and I were colleagues. We used to share the same office right opposite to each other in Milan, Italy. We're working on developing a forecasting methodology, technology forecasting methodology is so a lot of that experience you will see. After post that, Professor Dimitri and I have been in touch. You won't believe it, almost every week we talk to each other, and we've been collaborating ever since. So it's been a healthy share of ideas, sharing of ideas, and we co-created this course on technology forecasting, which Lochan Jolly ma'am was also there. She was kind enough to extend this with us. So thank you so much for having us over. So I'd like to start off with sharing my slides. So that's the first thing I'll probably do. Please let me know if you can see my slides.
Yes, sir, it is visible.
Okay, thank you, ma'am. Thank you for that. Okay, so both of us are professors and researchers. We continually try to see how to improve this methodology and how to make it useful for that. Very basic, this is my little background on my education and my fellowship at Polimi or Politecnico di Milano. This is where we developed the methodology, and which is what you'll be seeing. So I'll start off with the proceedings with the first and foremost question saying, what is forecasting? So I just want to go around the table and ask, what is your opinion? What does forecasting really mean to you? When I say the word forecasting, what really comes to your mind? What is it that comes to your mind immediately?
Anticipating about future.
Okay. Anticipating about future. Somebody in the chat says predictions. Excellent. Okay. Anything else? Anybody else? Anticipating the future, prediction. Okay. What else does forecasting bring to your mind? What does really forecasting mean to you? Giving insights on something, weather forecast, absolutely. That was probably the first thing that came to my mind when I signed up for the technology forecasting at Polyme. Giving insights or something. Thank you so much. Yes, absolutely. So it means so many things to so many people, but there's a time element, and there are things to look forward to, look into the future. That's what generally we look at forecasting as, the time element, right? So I'd like to showcase this painting to you. Have you seen this painting before? Lochan ma'am knows this. She's seen it in our course. Any guesses on what could this painting be about? You see two gentlemen on horses and three ladies right by the side. Okay, so this is actually not so far from, this is a painting which is hanging on the wall, not so far from where Professor Dimitri is. This is displayed in France. This actually depicts a scene from Macbeth. And this is what Shakespeare wrote, right? So Shakespeare wrote this play, a tragedy, and this is a scene from that novel, that about that play, actually a play where you can see the main character who's holding the horse's reins in the front, draped in red. That guy is Macbeth, and the guy behind him is Banquo. And they finish their battle and they come, and they are confronted by these three witches who say, or they give all sorts of predictions. So we are talking about forecasting. These women actually talk about some forecasts about what Macbeth will become. So Macbeth is taken aback because none of that has actually happened. So now he knows that those are all forecasts that they have. So initially he doesn't know what to do, but Banquo warns him by saying, if you can look into the seeds of time and say which grain will grow and which will not. Okay, so he says, Banquo cautions that this forecasting business is a very murky business. You cannot really for sure say which one is going to become true and which one not. So that's the premise around forecasting, is that you have no clue whether things are going to come true or not. So in fact, we do not take that at all into consideration, whether something will come true or not. What is forecasting for us is what, and some of you in the chat have mentioned that, is what are the insights for us today that you can take action on, which is what Macbeth does in the rest of the play. Not so good for him, didn't turn out so well for him, but that's exactly what forecasting is all about. We cannot for sure say what's going to happen, but if we know these things that might happen, potentially is a possibility, it equips us with action items, actions to do right now, decisions to take right now. Okay, that's the premise really. So what is technology forecasting? That's one another phrase that you keep seeing in our talk. I'll dissect this, and I've learned quite a bit deal from my discussions with our peers at Politecnico di Milano, as well as with Professor Dimitri himself. Is we'll dissect this phrase. We'll start with the word technology. Okay, so technology is what now we will talk about. We think of it as only the high-tech stuff, something that beeps and glows and does fancy things. That's technology. Possibly not. So I'm going to take a really old picture. Now you'll have to tell me what is it that you see and what do you think constitutes technology here. You can use the chat or just unmute and let me know. What do you see in front of yourself that constitutes technology, in your opinion? This is obviously a classroom. It's an old classroom, but a classroom all the same. What do you really see in front of you that can constitute as something that we're describing as technology? Okay. I intentionally took an old picture because the moment we show a modern picture, we'll say smart classrooms and all that. This is in no way a smart classroom or that kind of a technology. So what can constitute technology in this?
Photograph.
It's a photograph of a classroom. See anything inside the photograph. Okay, a board. This is a board that is there. Very nice. A blackboard. Absolutely. Thank you. Yes. It's a blackboard in the backdrop. Okay, that is probably what we can describe as the system here. We are trying to describe this entire system. Okay. Let me help you. Humans can also be considered as part of this technology because it's a human who's using this system, so to speak. Okay. So the teachers and the students, let's say, okay, some let's say, but those are just users. So let's have them as users of technology and not technology itself. Okay. The learning process, very nice, excellent. So the learning process itself, the students are learning, the teacher is possibly transferring, in this case, his knowledge to the teacher. So there's a learning process going on. Are the students allowed to leave anytime they want? Can they walk in anytime they want? Can they do that? This is probably in the 60s or 70s taken. I think they were allowed to do that even back then. No, thank you. So no, they were not allowed. So there are three elements in this that you saw, and you all of us described that, right? So one is the hardware, the chair, table, the blackboard, and the chalk that everybody is using. That's the physical stuff. Okay. Then you have the virtual, right? The learning process, the lesson plan, all that stuff that you don't see, but it's sort of there within it's going somewhere inside. Okay. Then what we describe as the rules or knowledge. Okay, that's things that are not allowed, sort of administrative stuff. These are the confines of the classroom. People who want to be in this classroom should be within that zone. Who are not supposed to be should not be within the zone. So all these, what we describe as hardware, software, and orgware. Okay, so we have a tiny formula here, so to speak, an equation of sorts, where we do this as hardware plus software plus orgware. Okay, all these three together form the technology. We always think that it's only the software or only the hardware, but there are rules to administer also. So things that sort of form the backdrop of technology also get into that space. Okay, so that is the first phrase. What about forecasting? Right, so forecasting has two elements to this. We describe anything in terms of these two elements. Whenever we describe in terms of time, so futuristic or from the past, we look at it. So if you want to know about the future, you have to know the past, right? So the time element is definitely there. Okay, and also scale or space. Okay, scale or space, because you could have classroom which fits into a school, which fits into the education system, for example, or the school has the classroom which has the table, which has the know how to put it all together. So that's again scaling down. So this is sort of how you can describe the forecasting process, or you can go forward. So these are the two terms, simply put. Okay, so when I show it in pictorial format, what it is each system evolves with time, right? It adds new features, it becomes more robust into the evolution. Sometimes other systems also merge with that, like your camera with your mobile phone. So it could also merge with the existing stuff. In scale, it could get larger. It could have expanding in various sectors, geographies. That could be expansion in scale. It could also take up roles of higher scale planes also. It could also do that. So in scale and time, it's sort of what I want to show it pictographically. Okay, so this is something that Professor Dimitri In fact, in his workshops, he has a section asking students what they think of this, right? So let's look at some of the common reasons why we need technology. One step before that is to also examine that this does not happen in vacuum. The technology or the forecasting itself activity doesn't happen in vacuum, but it actually is in a context. So that's the first thing we look at, is where is it operating in a school system, in a company system, in a startup. Where is this really, are we interested in? Where is the technology really operating in? That's the first and foremost step zero, to so to speak. Let's examine why we need technology forecasting in any context like this. So this is a depiction I have of why we need tech forecasting. Okay, so we've seen enough Bollywood and Hollywood movies to know why this person is taking the leap, because he wants to reach that girl. Okay, so he has developed an interest and he wants to reach out to that girl. Now he may succeed, he may not succeed, but what is this a symbol of? Is there's a gap between invention and innovation. Okay, innovation is when a product or a service reaches a customer. So we want, if you want to know, if you want to reach innovation, we need to know whether this gap is 100 miles wide or 100. How can we scale it? You need to know the surrounding stuff around the product itself, so that it can be useful to a customer, right? So that's the gap that we want to bridge, and this is one of the reasons why we do tech forecasting, is to figure out what is the context and what is the gap really that we have to scale, so that it becomes an innovation. Okay, that's one of the reasons why people need a technology forecasting. Another reason you will see, this is again something that we love to do. But before that, I have a question to ask you. Which is your favorite innovation? Okay, keep in mind that it has to already have reached a customer. Which is your favorite innovation? Just let us know via chat. What is your favorite innovation? Anything? Okay, wheel is your favorite innovation because it became useful in many which ways, and it helps people in many which ways. Okay, mobile phone, absolutely. Steam engine, brilliant, brilliant. Okay, safety pin, superb, superb. Thank you so much, folks. So innovation is when things become useful for us from being just something in a lab, and for that we need technology forecasting. The second one is we want to make sure that we do the right things, and this video here is a funny one, in which we highlight why you have to do the right things rather than getting things right. So this guy is going to do something. Let's watch this together. Okay, so he did all the right things, but did it for the wrong car, right? So our effectiveness depends on doing the right things, right? So that's another reason we can focus our efforts, but if you're in the wrong direction, it may not help. So technology forecasting actually helps you in making sure you're doing the right things. So that's another reason. There's a third reason, and this is even more important. Oops, sorry. Even more important than the first two, in my opinion, is working with limited resources. We'll see this small clip.
There are many big problems you have to solve, but we can use the same mindset that exists in Western societies that are filled with abundance to solve these issues. We have to go back to roots and understand how entrepreneurs, innovators in places that are suffused with scarcity like Africa, India, or South America go about innovating. When we studied them, we discovered that these entrepreneurs in emerging markets have a unique mindset. Let me illustrate how it works. In Silicon Valley, an engineer will come to work Monday morning asking himself the question, or herself the question, what if I can connect my fridge to my smartphone? Because we all have a fridge at home, and if I run out of milk, it would be nice to get a text message so that on the way back home, I can fetch a gallon of milk. But someone in India asked himself a more fundamental, what I call a big what-if question. What if you can create a fridge that operates without electricity? That's a big what-if question because 600 million people in India don't have access to electricity. And this question wasn't asked by someone who has an MBA or PhD, but someone who didn't even finish high school. This is Mansukh Prajapati, who has invented, in my opinion, the world's greenest fridge, which is made entirely of clay. It's called Miti Cool. It actually consumes no electricity. It's 100% biodegradable. It just uses the principle of evaporation, and it absorbs the heat, and it keeps the coolness and the humidity inside these chambers. So in the process, you can keep fruits and vegetables fresh for 5 days and milk fresh for a couple of days, which is a boon for 70% Indians who live in remote villages where food supply is intermittent. When we studied this example, we noticed that actually resource constraints is not a limitation for these entrepreneurs. Actually, it's a spur for creativity and innovation. It is possible to do more with less. That means you have fewer resources, but you can optimize what you have to create more value.
Okay, so indeed, more with less. So there are resources that are limited in many systems. So we want to know how to effectively work with them. So that's another reason why we need to know what's happening with the technology itself. So we need the forecasting. So 3 reasons. One is invention to innovation gap, or how wide is it? Second is doing the right things. Third is working with limited resources. So who or what do we need in the process? So how do we actually put together a technology forecasting team? What all do we need, or who all do we need? We can go back to our friends in this picture. According to me, the team should be a beneficiary or the user or the decision maker who can actually think about what is needed. So if you saw there's a customer or the user who will be the beneficiary of the process itself, or the decision maker who's going to make it happen, who's going to make the leap, right? So we need that person. According to me, that's Macbeth in that question. Banco is the analyst who will objectively look at the system, past, present, and the scale also, and analyze whether are we going in the right direction, what are questions to be answered for our beneficiary. So these are few things that we do. Third process is third purpose, a set of people we need are experts who, because analysts have a certain how the system works, but we need to involve and talk to experts to get inputs into our system so that our understanding of our system becomes better than what it used to be for the analysts, that is. So for me, these are the 3 sets of people we will need as a team. Okay. So a big question of how do we now forecast technology? I told you who needs to be there, why do we need to do it, but how do we do it? Okay, so to make life easier, we have an acronym called FORMAT. Okay, it's for formulate. That's the first step. You formulate the project. You put together a technology forecasting team. You need to know the business context. Who is the beneficiary? Who are we going to involve as expert? A project plan. We put it all together. The why, the how, the what, the who, all that we put together in the formulate step of the project. In step 2, we model the system. We try to understand what is the system all about. Why are we even working on this? How does it work from the past into the future? What does it? Where does it feed into? What does it consist of? So some of these, what are the drivers? What are the barriers of the system evolution? All that sort of, we break the system down into its components and observe it in tinier detail. So that's what modeling is all about. Then we mine for data as to what really happened on in the system, in our understanding. Where does data, we mine for data in all the variables that come out of our modeling. What is really important for our system to evolve? We take that and we proceed forward with that. And finally, the T stands for transferring. So the beneficiary is now keen to find out what is it that you guys came up with. Does it answer my context? Yes or no? And then we get the results. We present it back as a report, as a presentation, as answers to their questions, beneficiaries' questions. And that's how the project is complete. Okay. So you can find all this in a handbook where you can take it up and run technology forecasting projects on your own. This is a project that, wow, a lot of noise you can hear. Is there a question somewhere? No, okay. In the handbook, you can find methodology, the entire methodology itself laid out with detailed steps, far more than what I mentioned here. And you can download it and use it yourselves. So that's what the handbook is all about. So that was sort of my kickoff, my introduction to technology forecasting itself. And over to Professor Dimitri to go into a little more detail as to how it applies to the education sector and what does it mean dealing with data. How do you deal with data? What is the big, smaller picture of technology forecasting itself?
Okay, thank you very much, Bala, for nice warm up of our presentation. And I believe what I'm going to share right now will be much more better understandable after what you said. I'd like to say that I'm really happy today to be with you. Thank you for inviting me. Can you see my screen? Just
Yes, Dimitri, we can see
Yes,
it.
Yeah. Okay. In fact, the project format that Bala started to talk about at the beginning, it was a project which was several years European project, which was organized in order to develop methodology for manufacturing industry. What we are doing now, we are regularly teaching technology forecasting to our students. And today we are going to share with you some concepts and some suggestions that appear out as a result of several years of teaching technology forecasting to students. To my mind, it's kind of very specific experience because all the courses that you can see on my screen, they were delivered in different engineering schools, in business schools. They were delivered mostly not as a mandatory course, but as a course that students subscribe just because they're interested about. The main issue is that starting from 2015, one of the output of format project, this is a course about technology forecasting and research in future, which is delivered at Politecnico di Milano. This is 64 hours course with 6 credits. This is a master course. I also delivered the course Innovation and Problem Solving and Innovation and Strategy at ECAM Strasbourg Engineering School. Technology forecasting for strategic decision making. This is what we built with Bala for NPTEL initiative, and we already run it 2 years. And this year, I already applied some fundings to teaching technology forecasting, an introduction to innovative intelligence course, and technology and management of information system. In fact, okay, particularly me, right now, I'm a researcher at the Humanist Laboratory at EM Strasbourg, but I'm delivering every year the courses at Politecnico di Milano as a visiting professor. okay? And within the last 7 years, it was a regular courses about technology forecasting, and we are interested to share with you some experience and some findings and some ideas, and let's discuss it together how it can be useful in context of what is discussed within these several days faculty development program about Education 4.0. But all these courses, they are all about the central question, how to forecast reliably technology changes. Okay, this is the main topic that we are interested to answer. How to forecast reliably technology changes for supporting strategic decision making. And this practice is useful not only in the context of technologies. This practice is useful for many different contexts. What is our agenda, at least part of our agenda that I'm going to deliver, and Bala, he will be back in the 30 minutes, and we will switch in order to help you to learn better from our experience. Okay, first of all, I'd like to say that our talk is not about school education. Okay, our experience is from higher education context. What we are going to talk and what we are talking about is not about forecasting the future of education in India. We still did not perform this project. We still did not perform this activity. And it would be nice to be done, especially when we are talking about some reforms. Our talk is not about information system or information and communication technologies in education. That a very popular idea to talk today, especially as soon that we have a very particular experience after pandemic situation. And we like to so much today to talk through the ekrans, through the screens, not directly to our students. What is it about? It is about some outcomes from higher education, from teaching technology forecasting in higher education context. It is about what you already heard many times within this faculty development program about STEAM and OBE. Okay, do you remember what is STEAM standing for? Science, technology, engineering, mathematics. And OBE, this is outcome-based education. Okay, this is the central question that I'm interested to share with you. We are interested to share with you. This is why it is relevant to teach and learn technology forecasting and higher education. When we are talking about higher education, we are talking, for instance, about Institute of Technology, Institute of Management, different kind of business schools, and different kind of bachelor and master programs. This is the main idea that we would like to share with you. So let me start with a very wide context. This is a sketch of black box model for higher education. Okay, the black box model, usually we have input output without taking so much into detail what is inside of the box. And if I take a box as a black box higher education, we can see that at the input we have a result of school education and results of professional education. And we use these results in order to form and to have educated specialists. What does it mean, educated specialist? Those are specialists that they have needed knowledge, skills, competencies, attitudes for what? To be competitive on labor market. On labor market today, not only on the Indian labor market, but on the worldwide labor market we're talking about. Also, we have entrepreneurs, we have researchers, we have scientists, we have teachers, which becomes professors, and they becomes either a mechanism in order to run higher education. But what are the limitations? What are the contexts which put kind of rules? You remember Bala already told you about orgware, okay? Those are the economic changes Those are restrictions from climate, pollution, resources changes. This is changes on the employment landscape. And those are changes, they are permanent changes. It's not something that happens and after that we can take it. Those are that we have to take into account permanently, the changes. Those are the changes of population, structure of population, also global ecosystem, available energy, water, food, and other resources, our needs. What are the mechanisms that we use in order to run higher education? The mechanisms, those are the institutions, universities, colleges, faculty members, invited professors, students. Without students, it doesn't work, okay? It's also about traditions of education, which are different in different countries. Those are the value of education in society. And we can see that value of education in society in India is different from value of education that we can observe in different other countries, including European countries. It's also legal institutions that make regulation of our higher education. So when we are talking about forecasting, we need to be capable to predict reliably those changes in order to get our educated specialists in time exactly with necessary knowledge. And this is not only about using or not using information technologies and communication technologies. Because where is from Education 4.0? Okay, Education 4.0 comes from the famous concept of Industry 4.0. But if you look carefully to the definition, what is Industry 4.0? This is a rise of digital industrial technology, okay, which transformation allows to work alongside machines in new way. I would like to emphasize alongside machines, not people. Highly productive way. So it's once again about question of efficiency, not about effectiveness. We would like to improve efficiency of our industry. And in fact, when we are talking about context of education, we are talking about specialists which will be capable to run all these processes, to monitor them, to design them, to improve them, to, if any failure appear, to repair them, okay? But it is Industry 4.0 by itself, it's not about people. This is more about automation. So we are talking, and this is not only a question of education of engineers, not at all, because there are managers, there are human resources, there are a lot of issues which are connected with these changes. So if you look to the Industry 4.0, usually people are talking about that they're based on 9 main pillars. 9 main pillars, those are the big data analytics, those are the horizontal and vertical integration, cloud computing, augmented reality, industrial Internet of Things, additive manufacturing, autonomous robots, simulation of digital twins, cybersecurity. Okay, if I look just to this picture, I say, okay, we need specialists in each of these domains. This is what is on demand. But let's be careful. Do we really need them tomorrow? Or probably we will need them a bit later. For this, I'd like just to share with you just about one pillar. I would like to share with you the final presentation of one of the project of students, which was delivered to Politecnica di Milano in order to defend their final project and to be evaluated about result of the course. Let us see together this video presentation, and I believe that you will enjoy, because this is what can student learn within 60 hours of the course and what they can deliver as an output. Okay. Now I'm going to share with you video, and you will.
Additive manufacturing is a technology that enables us to build 3D.
I have a question. Can you hear the voice and can you see the video?
Yes, Dimitri, we can hear the voice and also see the video.
Okay, let's go ahead.
3D objects by adding layer upon layer of material. But why additive manufacturing? Additive manufacturing is an industry that's growing at an average of 15% every year, and in 2017, it had a global revenue of $7.3 billion. In the light of this growth, we find it worthy to forecast. In this industry, United States is the main leading force with 42% of the global revenue, and they are continuing to lead the advancements in the technology. But why would companies prefer additive manufacturing? Additive manufacturing methods are applicable to lots of industries, and it brings incontestable advantages in replacing conventional manufacturing methods, such as more than 50% reductions in weight and cost. So, what are we forecasting now that we have this information? When will additive manufacturing processes start to be adopted instead of conventional manufacturing in the United States over the next 8 years? Our sub-questions to help us answer this question are: which industry will benefit the most out of replacing with additive manufacturing? And what are the key performance factors that will cause a transition to additive manufacturing? Finally, why are we forecasting? We are forecasting to decide the best time to start replacing current machines with additive manufacturing machines.
Fundamental to the forecasting process is the definition of system performance characteristic, which is the ratio between the function of our technical system, expressed in simple terms, and the expenses, which are essentially the resources consumed by our system to achieve its function. In our case, the system performance characteristic is to create components out of metal, plastic, ceramic, resin, divided by materials, machine, time, energy, and space. During the process of evolution, this ratio tends to improve for a growing system. With function of our system as the epicenter, the system operator is developed. It involves defining the current super and subsystems and verifying if the elements of these systems are consistent with their respective counterparts 8 years ago. Once this consistency is verified, the possible evolution of the supersystem in the next 8 years is formulated, and based on that, the function and the subsystem for the year 2026 are derived. A consistent system operator is the foundation for the entire forecasting process. Every future step traces back to it. According to the system operator, the two primary trends of additive manufacturing for the year 2026 will be the improved modularity of the machine.
Additive manufacturing started in the 1980s in Japan and has been initially commercialized in the year 1990 with very little impact in the manufacturing industry. Today, additive manufacturing has become more and more popular in the industry for its various advantages in manufacturing. The S-curve represents cumulative growth in the market revenue of the United States while adjusting to the inflation rates over the years. The historical data provides the trend's tail, and the more recent values were used to extrapolate the future trend. The plateau is forecasted to be in the year 2044, reaching a cumulative market revenue at an estimated of $264 billion. It's predicted that the additive manufacturing will be substituted with more advanced technology after the S-curve has reached its plateau, creating a new trend. The drivers and barriers were categorized under 4 main tendencies: technological, economic, environmental, and social. The tendencies collect the current required improvements needed to be able to reach the predicted supersystem mentioned before. The technological tendencies cover the need for modular equipment to reduce multi-material components, as well as reducing assembly to manufacture more complex parts easily. Economic factors face the printing speed situation, as this is one of the main deal breakers of additive manufacturing, in addition to the cost of production. Environmentally, the demand for minimal waste and scrap is increasing due to many reasons, such as material costs increasing and governmental constraints. Socially, the competition is expected to increase, therefore requiring more employees. These questions were derived from the barriers to have an overview of the major problematic aspects and develop solutions to overcome them, such as how to decrease negative environmental impact, Each question was then built into a contradiction, stating the problem, operating time and zone, and evaluating the pros and cons for each possible outcome of the problem. Here, the most important contradiction was presented, showing that the research and development sector has the largest impact to the future of additive manufacturing.
By first grouping together the system elements and features with the desired results of each contradiction, the measurement units of each were then found to better describe the results. Based on these units, the elements and features were split into 5 families: costs, time, quality, flexibility, and energy. The elements and features were compared to the initial tendencies to define the relationships between the individual elements and features. Gathering this information, the contradiction map was drawn where the hierarchy of each set of elements and features, as well as their effects and the most important groups, can be better understood. The cost and time show to be the most important group's families, with quality being on the second tier, and the most affecting elements are research and development, the number of assembly components, and the product complexity. To further refine the forecast to its second generation, we focused on 3D printing and CNC machining to represent additive and conventional manufacturing, respectively. Then, by comparing measured values of all 5 families, this spider diagram was drawn to show the values of both technologies. This is under the assumption that better future values should be equal to or greater than the highest percentage of each family. The system operator and tendencies were then re-evaluated to ensure consistency. According to the data found for each of our families, CNC machining only surpasses additive manufacturing in terms of costs, such as machinery and production costs, by a small margin, and comes in a close second in time when comparing values like production and lead time. 3D printing shows to surpass CNC machining in the other 3 families of energy, flexibility, and quality. Considering the limiting resources and the research and development activities for each set of elements and features within the scope of the 8 years chosen for our forecast, the exploration and implementation times were estimated, and the total time needed to overcome the main barriers were drawn out to build the roadmap seen here. Research and development, as well as the accuracy of manufacturing, will need 4 years to overcome the barriers, and almost all the rest of the element sets are estimated at less time except for the cost of raw materials, which shows to be outside our predefined scope.
A set of features were defined to better describe the system. The features listed are listed in a way of decreasing importance. The main feature we have is the increase of research and development, and as a result of that, the decrease in the production costs per batch of products manufactured. This is the most important feature since research and development is the most crucial element, and the cost is one of the most affected groups according to the contradiction map. Therefore, it is the first feature here.
Now, the forecasting process has generated all the information and knowledge required to answer the questions. Let's start with the basic ones. What are the key performance factors that will cause the transition to additive manufacturing? They are R&D, number of assembly components, and product complexity. Which industries will benefit the most from additive manufacturing in the next 8 years? Based on the data we used for our forecasting, the top beneficiaries are automotive, aerospace, dental, and medical. Let's move on to the main forecasting question. When will additive manufacturing processes start to be adopted instead of conventional manufacturing in the US in the next 8 years? Well, according to the logistic S-curve, the adoption 2022 and 2034 would be the best time frame for the additive manufacturing. When is the best time to invest in additive manufacturing? The decision-making question can finally be answered now. The best time to commence R&D to prepare for the beginning of the growth phase in 2022 is now. This is because it would take 4 years for the R&D to reach a level high enough to overcome our primary barriers. As per the contradiction map, R&D is ranked at the very top. Thank you.
Okay. this presentation probably it is a bit longer than usually YouTube 3 minutes presentation, but I believe that it gave you some ideas how it looks like the technology forecasting in the hand of students. Once again, those was done by students within a limited period of time as the result of what they learned within the course. We will be back to this topic a bit later, but now I'd like just to explain to what we start with our students. With our students, we always start with learning and mastering what we name fact-based thinking. And first thing to think about future, according to our limited experience, is to know about the present. And what is interesting to see that this knowledge cannot be extracted from experts and specialists. And these results are confirmed by another research in forecasting, that the higher expert you have to ask your question, the lower accuracy result about future you will have. Okay, let us do some experience, something like we do with our students. What we are doing with our students at the very beginning of the course, we pass the test on the gapminder.org, and the students, they have to deliver the certificate in order to update their knowledge about what really situation is, not what they think about, what they believe about. You can go to this website and you can update your worldwide view by yourself later on. Now, I'd like just to take two questions in order just to illustrate what we are talking about fact-based thinking, okay? For this purpose, I would like to invite you to the Mentimeter, okay? Let me share with you what are we going to do right now. Okay, please, with your mobile phone or with your computer, go to the menti.com. You use this code and you answer this question. What do you think about? Please do it right now. I took this question from one of the questions that you can find at the Gapminder. The Gapminder, it's a very good tool to my mind to practice with our students, to practice. Okay, as soon as you submit something, we will see the result on the screen. Can you see my screen with question?
Yes, Dimitri, we can see the screen.
Good. Please submit. See if the better it is for what we are discussing about. We have more than 70 attendees. I expect to have at least 30 answers before we will go to the next, before we will proceed to the next question.